All right, so we just talked about ionization energy being the energy required to pull electrons off. Now, here's the flip side, electron affinity. This is the energy when we add electrons in. Most of the time, not all, but a lot of the time, we actually get some energy when we add electrons in. All right, and so when I look at this, we've got the energy change that is occurring when an electron's added in the gaseous state to an atom or an ion. Now, because this is usually favorable, a lot of times it's not going to cost any energy, but we'll get energy from it. Again, most of the time, not always. All right. And so because of this, electron affinities are oftentimes negative. Now, here's the thing with electron affinity, though. This is a lot more complicated than ionization energy. Ionization energy, we saw a very definite trend that ionization energy increases as we go across the periodic table. And then depending on the type of electron that we're pulling off, we see those dips, and then it goes back up, and those dips, and those goes back there. So you would think that for electron affinity, we would see the same sort of like general trend. No, electron affinity is a little bit crazy. It kind of bounces out around quite a bit. Electron affinity is far more type of electron dependent than even ionization energy is, and so they bounce quite a bit. And so the trend is, as I go across the periodic table, they get more negative-ish, maybe. um, but then when you look at fluorine, and it goes up on chlorine, and goes back down bromine, and then down on iodine. So electron affinities are a little bit crazy. And so you can see here where we've got quite a few negative electron affinities. So we're getting that energy back, but then a few of them get positive because it actually takes energy to shove that other electron in, depending. Like when I go from 1A to 2A, my 1A electron affinities are negative, so adding another electron in, that makes sense, we're spin pairing. But then when I go from 2A, well, now the electron that we're adding in goes into a new subshell, goes into the p subshells. And so now they start costing energy. So electron affinities aren't quite as well defined as some of our other trends are, but it's the energy when we are putting another electron in.